Hello, Cal State Strab, Moles. Hope how we're doing. We're getting there. We're on the very last notes for chapter 12. And we so far have done tests, a Z test when we, for means, when we didn't know sigma. When we did know sigma. And then we're doing the T test for means when we didn't know sigma. We also talked about a paired T test. And by the way, I just watched the webinar for the exam, and it's very likely a paired T test could be something they talk to you about on this test. And then now our next one that we're going to talk about, our next inference procedure, is a Z test again, but now for the population proportion. Okay. What I love about teaching these chapters now is that we've done all the hard work of getting everything understood for our state plan to conclude, and we're just going to now see how is it different when I go to proportions. Okay, so now our parameter is a p, the true proportion, right? Not it was mu for means, and now we're doing p. So our ho and our ha are going to be written in terms of our population parameter p. So we start off with, just like we did before, the ho is p equals. The ha is that it's either going to be greater than, less than, or not equal to, sorry, my phone's going off there, if it is two-tailed. Okay? One-tailed, two-tailed test, just like we did. Conditions are the same. We need to check them. Why do we need to check that it's SRS? Remember, I told you this is the most important condition. We need to make sure that the sample we are getting represents the population. If it's not randomly chosen, we learned that back in an earlier chapter. If it's not randomly chosen, then we don't know that it represents well the entire population. So we must have the SRS. It needs to be normal, so we can use the Z. Well, why normal? What's the reason for normal? To use the Z score. So in order to check for that, this is the difference between mean. CLT worked for means. CLT does not apply to proportions. No. That's the number one mistake. Students will go, oh, n equals 100. That's greater than 30. Check. No, not for proportions. You have to do NP, and n times 1 minus p greater than 10. However, that is not new to us. We did that for CIs, confidence intervals. We're still doing our large number test of 10n has to be less than the population, and that gives us the independence for the condition met there. So now go back to our Z statistic, only now it's with proportions. But just like it was for means, it's the estimated minus the hypothesized values on the top. Recall back from when we did confidence intervals, that the estimated value for our proportion, our population P parameter proportion, is P hat. That's our estimate. So there you see P hat minus P null, the proportion of the null hypothesis, the claim. Okay, and then here's the tricky part. In the denominator, this is different than CI. In CIs, we used P hat. We didn't have a P null. We had a P hat, and that was the only thing we could use to be our estimate. And if we weren't given a P hat, we used 0.5, if you remember, to run our CIs. If we are not given a proportion, then we use 0.5. Well, now we're given this null hypothesis amount, and that's the part that goes into this formula. So this is where it's hard to remember the difference between CIs and testing, significance testing for parameter of proportion, okay, is that now we put P null here, not P hat. But it's kind of easy to remember when you do a CI, I don't have P null. I don't have a null hypothesis for a confidence interval. I do have a null hypothesis for significance testing. Okay, so we're going to run this test statistic for Z now. Estimate minus the null hypothesized value divided by the standard error for the proportion using P null. That will give us the P value that we're then going to go get from the table, right? We get the Z, go to the P value, and then just like before, compare that to alpha and come up with your conclusion. Okay. So just a reminder, we're using P null is the P of the null hypothesis. Your sketch is going to be exactly the same. Your P null goes in the middle now. Your claim, your hypothesized value is in the center. Okay. If it's one-tailed, this is an example of a one-tailed sketch, Then the p hat is our estimate, and we plot where it falls in comparison to the hypothesis. Okay? And then our SE is that denominator that's in our test statistic on your formula sheet as well. It's just on the formula sheet, they don't tell you the difference between P null, P hat, when to use the different ones. So that's something you have to have up in here on your hit. As a matter of fact, since you get to use notes for this test, I would recommend you write that on there, the difference between CI and the test. You can put that right on your formula sheet. Normally in the past, you can't have that for your tests, but you guys can. So check there, okay? All right, but anyhow, that's what you mark off as your standard error until you get to your estimated value, and then you shade in, just as we've done before. So let's do an example. A college has published that 10% of its graduate students are looking for housing. 481 graduate students are randomly chosen. There's our SRS. 62 are looking for housing. Is there statistical evidence to believe the percentage is higher than the college believes? Okay, well, the college claims it's 10%, right? So we're going to go to our state, and before we do our ho and our ha, we're going to state what our parameter is. Parameter is the true proportion of grad students looking for housing at a particular college. Actually, to finish out your population, you would say at this particular college, okay? So here's your ho, P equals 0.1. We're wanting to see if we have evidence that it could be higher than that. So there's your ha, greater than 0.1. And no significance level was given. So remember, we let it be 0.5, just as before. Okay? SRS was given. Normal now is NP, and N times 1 minus P. So we use the P values from our hypothesis here, and we run this off. Sometimes students use P hat instead of P here. Remember, you're using NP, N times 1 minus P. They both must be greater than 10, and they are, so the normal condition is met. Our large number condition, or independence, 10N is 4,810. So we're assuming that there's more than 4,810 students at this university or college, okay? I should say graduate students. So then we do need to calculate the P hat. It wasn't given to us directly. So we're going to look and say, well, we got 62 out of 481 in our sample, right? So that's going to give us a P hat of 0.129. Okay, moving forward, we go to Z statistic. So we just did the state, the plan. Now we're on the do. And there you'll see my hypothesized value is here. This is the estimated value, P hat minus P null. And then we're using down here P null, not P hat, P null, and then divided by N, square rooted. And anyhow, I get a Z of 2.12. Going to my table is 0.9830. We're all really adept at this now. We said, oh, but this is a right-tailed test. So the next step I need to do is to subtract that from 1 to get the right-tailed probability, and I get 0.017. Okay. We're going to go, let me move myself out of the way here. Going to say since p-value is so low, because 0.017 is definitely less than 0.05, there is statistically, I prefer it said statistically significant evidence, enough evidence at the 5% level to go ahead and reject the ho and conclude, always in context. The webinar, again, so many times the writers of the test were saying, if you don't put context, you're not getting all the points. So we always got to remember, we can't just say reject the ho and accept the ha. What does that mean in context? It means we're going to conclude that there are more than 10% of the graduate students needing housing. We need to give that information to the college so that they know that they're underestimating their needs. Okay. All right. Before we go into a big practice problem with the worksheet, I should mention that. I should have mentioned that at the beginning. You need that worksheet significance test for a proportion. It was in your pacing guide. So you're going to want to print that out and have that handy for after we finish the notes here. But before I go into that worksheet, I want to go over 2 of your 3 homework questions, okay? If you're paying attention to this, you're going to get most of it done right here. Number 24 asks you to compare the differences between running a significance test and running a CI. This is huge, super important, so that's why I'm putting it in our notes. Okay, so the claim in the question is that 73% of first-year college students say well off is an important goal. So you get an SRS of 200 and 132 of those people say this goal is important. All right, so we know that P is 0.73, right? Change that percent into a decimal for P. And we know P hat by doing 132 divided by 200 is 0.66. So let's look at this side. On the left, I've run the hypothesis testing for you. You set up your Z statistic. I just put the formula there to remind you, okay, that you'll need to do that and then get your p-value. So I put in the values and get a Z of negative 2.22, which goes to p-value of 0.0132. This particular question is a two-tailed. It doesn't give you a direction, so we need to remember to multiply that p-value by 2, just like we did with all the other testing. Okay, if it's two-tailed, this p-value is only giving you one tail. You've got to times it by 2 because it's symmetrical. Okay, so you get 0.0264 is still less than 0.05, so we're going to be able to reject HO and say that the true proportion that say well off is an important goal is not likely to be 73%. You can put your claim back into a percent in your conclusion, okay? Don't leave it 0.73. You don't usually say that out in the world. You would say 73%. All right, now let's take a look and compare that. Oops. Now, compare that to a confidence level, okay? If I was to make a 95% CI for this, okay, which relates, to that 0.05 alpha, same as 95% CI. Here was our formula way back from chapter 10. You're going to take your p hat plus or minus Z star for 95. And notice the difference here. We now have p hats in this square root formula, not the p null. It's what I was talking about, trying to hammer really hard. CIs use p hat. I don't have a p null if I was doing CIs. I don't have a null hypothesis. So I'm estimating with the p hat, our estimate. Oops, dang it. Come back. Okay, so here's your p hat plus or minus 1.96 is your Z star for 95%. Here's p hat times 1 minus p hat. See, notice the difference here. Okay, yeah, but still I'm going to end up with this CI when I do my math. Okay, when I notice that 0.73 is not in that interval. So what we talked about last chapter is that when a value is not in the confidence interval, then we're going to reject the HO. That's how you would compare it to a significance test. So we would be rejecting HO and say it is not likely 73%, just like we said with the significance test. They'd better match up because it's the same data, okay? But I'm just showing you either way, running it as a hypothesis test. If it says to run a significance test, you must do it the way on the left. If it says to run it with a confidence interval and show that they mean the same thing, or just run a confidence interval method and see if it's what you would do with it, with the null hypothesis, then the confidence interval tells us clearly we're going to reject the HO and see that 73% is not likely. Now remember, you can only do this method when it is a two-tailed significance test. Can't do it when it's a one-tailed test. So since this was a not equal to test, we were able to do that. So there's number 24, some good work there for your homework. And also, I'm going to give you some hints on number 25. It gives you some data and it asks you if Shaq has improved his free throw shooting. Okay? They give you the null hypothesis that he's shoots at 53.3%. If we want to see that he's improved it, we're going to do a one-tailed test going greater than that. So the p hat there is 26 over 39. is 0.67. Okay? Then it just wants you to talk about what the type 1 and type 2 errors would be for Shack there. Type 1 and type 2 there, remember, type 1 is that we reject the HO, but we shouldn't have. So we say that he has improved. When we reject the HO, we accept the HA. So we're going to say, oh, yeah, we reject HO and think that HA is likely. So he has improved, but he really hasn't, right? Whereas a type 2 error, remember, we failed to reject the HO, but we should have rejected it. So we're going to say he has not improved. However, the HA really is the truth, and we should have said that he has improved. So just some hints there. It's all the same we discussed for means. I just wanted you to see a little bit of it, and you can wrap up those homework questions on your own. All right. Before we go to the worksheet, just as with means, there are calculator commands that will allow you to do this work. Same thing, you go stats test, but now you go to the option that is a one prop that's for proportion, a one proportion z-test. When you're writing the procedure on your test or paper quizzes, you could say it's a one proportion z-test. A one sample z-test for proportions, okay? Or you could say it's a one prop z-test like this when you're using the calculator commands and you're writing it down, what you're using, okay? Now here's the things you're going to enter. You'll have to enter your null proportion. You'll have to enter X, which is like how many out of N, the total sampled. So like I can't remember the numbers in the last problem, but if we had 42 out of 100 people say something, 42 is the X, 100 would be our N. Then you tell it whether it's one-tailed, two-tailed, left or right, and hit calculate. When you're done, it will give you the Z statistic. It'll give you the P value. It'll give you P hat. It'll calculate that X over N for you. And of course, it spits back out N, which you already know. But you're going to be given those values just from running a one proportion z-test in your calculator. Really nice. Just like with the means, when you run a test in your calculator and it's two-tailed, no need to times this answer by 2 because the calculator, when it sees this not equal to here, it knows to do that for you, okay? So don't times it by 2 if you're doing the calculator test, only when you're doing it by hand. All right, I'm going to ask you to have that worksheet in front of you now, significance test for a proportion. And you have a situation here that I'm going to ask you to do a state plan, do conclude, and give me your answers through Edpuzzle. And then we'll be done today. So this is another situation about a fast food restaurant and its drive-through customers. We've talked about this a little bit. Okay, so he wants to reduce that proportion of time, that the proportion of customers that have to wait more than 2 minutes to receive their food once their order is placed. So he says here, based on store records, the proportion of customers who had to wait at least 2 minutes was 63%. That's our null hypothesis there. To reduce this proportion, the manager assigns an additional employee to assist with drive-through orders. During the next month, the manager will collect a random sample of drive-through orders and test the following hypotheses. So he wants it to be shorter than that, less people that have to wait 2 minutes or more. So he is going less than 63% for his HA. Okay. So suppose the manager decides to carry out this test using a random sample, important there, of 250 orders and a significance level of 0.10. Alpha is 0.10 this time. All right, so if he gets 144 of the 250 randomly selected drive-through customers had to wait at least 2 minutes, what conclusion should the manager draw? So when it's asking this, it says now to justify this with a significance test. So you're going to do state, plan, do, conclude, sketch. Also, I want you to tell me what is the probability of a type 1 error in this situation. The back of this worksheet asks you to calculate probability of type 1 and type 2. When I show you the answer key, I will put up for you my calculations of beta and a type 2 error. But based on this year and the things that are going on, I am certain you're not going to have to do that on the AP test, and it's quite complicated. So for those of you who are interested, you could just take a picture of it and chew on it, but it's nothing that you're going to have to regurgitate from me. All right, so if you'll do that and come back and look at the answers. All right, let's see how you did with your state plan do conclude. So with our state, we are doing the true means, I got mean stuck in my head, the true proportion of customers who had to wait at least 2 minutes. And there's our ho and our ha that were already stated for us. We are running a one sample Z test for proportion P. Right? Conditions, SRS was given. You needed to do N times your P null there. And both of those were greater than 10, hopefully, N times 1 minus P also. Independence, your large number test to see if you've got enough testing going on there, the right number tested. And we get 2,500, which is probably, we're going to assume, less than all the customers that come through the drive-through. We're going to have to assume that. Do, there's your P hat. You calculated it at 0.576. So now you'll see all the work here. I set up the statistic P hat minus P null times 1 minus P null divided by N square rooted. You need to put that value off to the side because that SE right there, the standard error, is what you're going to use to mark off your sketch by about 0.03. Okay. Here's my Z statistic. So I then went to the tape and got a 0.0384 for the probability, the p-value. Okay. We're doing a one-tailed test, so it's not multiplied by 2. If you went to the calculator and used the calculator, you did a one prop C test, and it will tell you 0.03849. This is getting a little bit more accurate here. It's actually closer to 0.0385, isn't it, than 0.0384, but remember, we're going to get more accurate with the calculator. Okay. Then your conclusion, since our p-value is less than 0.10, we're going to reject HO. We have statistically significant evidence that the wait time for our customers has decreased. We can accept the ha since we're rejecting the ho. From 63%, down, we're going down from that. So the manager should keep that additional employee on the drive-through. That's my added piece of conclusion there, because that's what the manager is trying to decide. Did this work? Did this help? So I put this person on, and I have great evidence to show that we have reduced the proportion of people having to wait more than 2 minutes. So let's keep that employee on the drive-through. Hopefully you came up with the type 1 error is 0.10, because remember, type 1 error is the same as alpha. So you just had to read that from the problem. I already mentioned to you that you don't have to stress over this type 2 error calculation, but I'll show you I did the work there to find the beta to be 31%, 0.3. So we have a 31% chance of making that error where we failed to reject HO when the HA was true. So that gives us a power on this test of 69%, which is not very high. Remember, we want it to be 80% or higher. But remember, our alpha is only at 10%. So with a higher alpha, we're going to also have lower power going on there. Okay. I happen to use a calculator command here to find my 31%. So again, if you wanted to take a picture of this or a screenshot of this and just chew it over later, there's that sketch I showed you earlier on in the when I was teaching you about beta, and I just made it for this particular situation and found where that would lie. However, don't stress over that. If that seems too difficult to chew on, just let it go. All right, that's it for today's notes. Tomorrow, I'm going to go through the worksheet real quick before you take the quiz. So make sure to watch tomorrow's notes as well before taking the quiz on proportions. We're going to do one more big example. All right, have a good rest of your day, and I'll see you with notes tomorrow.